Hey guys, welcome back to another video. We're doing chapter 17, number 94, intro, the second edition. And it says calculate the molar solubility of MX. We don't know what MX is. All we know is KSP is 1.27 times 10 to the negative 36 in each liquid. And we know it's a 1-to-1 salt. So whatever it is, whatever the metal is, whatever the non-metal is, it's 1-to-1. So it could be barium sulfate. It could be, I don't know, it's probably going to be a 2 plus 2 minus. We don't know what it is. We don't care. So let's go. Well, it definitely is 2 plus and 2 minus because M is CO2 and Na2X. So pure water. Let's look at A first. So pure water, we know that MX solid is going to go into M2 plus aqueous and X2 minus aqueous. And we know that because if you look, the context clues for B and C, chlorine obviously is -1 and sodium is always +1. So that's how we know that the metal and X are plus and plus 2 and -2 respectively. So in our ice table here, I just have to have some, right? I have some solid. So 0, 0, plus X, X, and X. Our KSP expression is equal to M2 plus times X minus. We know KSP happens to be 1.27 times 10 to negative 36 equals X times X, or X squared. Square root both sides. X happens to be the concentration of I keep on writing Mg, but it's Mx, which happens to be 1.23 times 10 to the negative 18. And that would be the concentration or the molar solubility of Mx in pure water. B. For B, it's the same Mx solid, M2 plus X2 minus, and those are both aqueous. So now in my ice table, I have some Mx. However, we have 0.25 M, right? 0.25 M and 0. And remember, my common ion, which in this case would be M2 plus, addition of common ion always suppresses the ionization of the weak electrolyte. In this case, Mx would be the weak electrolyte. Change, equilibrium, the change is still the change, and that would be, right, all the way down, doesn't matter here, plus X and plus X, so I get 0.25 plus X and X. So KSP is still M2 plus X minus. I get 1.27 times 10 to the negative 36 equals 0.25 plus X and X. What we can do here, we can approximate this to 0 because it's more than 10 to the third difference. So I get 1.27 times 10 to the negative 36 equals 0.25x. Solve for x. You get 5.08 times 10 to the negative 36 molar equals x. And that happens to be the concentration of mx. So that's B. For C, if I scroll back up to C, I'm in 0.2 molar x. So I still have mx, m2 plus, x2 minus, 0.2, is it 0.20 or 0.2? 0.20 molar. So 20. We have some solid in my ice table. So 0 plus x, x, and x. And we can do the same assumption here. So I have KSP is equal to M2 plus x2 minus, I forgot the 2 minus up there. Let me fix that. So this gives me 1.27 times 10 to the negative 36 equals x and 0.20 plus x, which is the same thing as 1.27 times 10 to the negative 36 equals x times 0.20. So x equals, I think it's 6.35 times 10 to the negative 36. And there is 1794.